Good afternoon, everybody. Welcome to the Blue Vigil live stream demo of our latest product, the M300 Tether solution. Appreciate you taking time out to join us this afternoon, along with our host, WS Darley. Before we get underway, just a couple of housekeeping items. Keep in mind today's session is in webinar mode, so that means as a participant, you will not have the opportunity to speak live, but there's a couple ways to communicate. First, if you have a question, and we really encourage those throughout the afternoon, please go ahead and use the Q&A submission function in Zoom to make that happen. And then chat is also on. If you want to chat amongst yourselves, you're certainly able to do that. So just to get things underway, I want to go ahead and turn this over and introduce our friends from Darley. We've been working with them for a long time. They are a great partner in the public safety space. We have both Nick Fay and Bruce Ireland with us today. So I'm going to go ahead and turn it over to Bruce.
Thank you, Carl, very much. And I apologize up front. I'm in the back seat of my truck as we're out flying some drones with some police departments here in Texas. But thank you, everybody, for joining. At the end, if there's anything that any questions that I can answer from the Darley side of business, please let me know, and I'll make sure I get you the answers. If there's anything that we can be doing to support you and your agencies, make sure you let us know. Feel free to reach out to me.
Excellent. So next, I'd like to introduce to you the Blue Vigil team that's going to be with you this afternoon. Again, my name is Carl Miller, and I head up our partner programs. With me in the back office, I have Kathy Welt. Kathy is the individual who did all the magic to make this happen today for us. Out in the field doing having the fun of flying drones and filming. We've got Todd Stave and Gerard Eldering, and I'm going to turn things over right now to our CEO, Rob Schumann.
Good afternoon, and welcome everybody, and thank you for taking time out of your day to join us. I'm going to cover a little bit of background. I don't know what you guys know about tethers or the Blue Vigil tether system in general. But before we get to the M300, let's talk a little bit about kind of our systems and how they work. So our tether solutions consist of a base station. This is our RS-1000 base station. It comes in both a 150-foot tether version and a 300-foot tether version. And this unit takes AC power in, so this can be 110 or 220 volts. It takes that AC power in, converts it into 400 volts, which actually is what's carried on the tether. And that's the magic that allows the tether to be so small and light in all of these tether systems. And then it also manages the tether. So it ensures that the tether is actively kept taut so that it's not laying on the ground, it's not disturbing the environment, there's no safety concerns on the ground. And more importantly, the active tether system is also what deals with wind and all of the effects of that. Okay, and we'll show that and talk about that a little bit more as we get into the demonstration. So this is the base unit, and you have a base unit, and then you connect up into the second half, of course, is the air units. And as Blue Vigil started supporting the DJI drones 4 years ago, the first DJI drone that we integrated with was in fact the Inspire 1. And you can see this is a little bit older solution, a little bit clunkier, but what it did is you have a TB47, TB48 battery that should come out of here. And it's a normal TB47 battery, except we modified the battery to add an XT90 connector so you could add the 6S voltage connection here. And then that battery connects to our BRM. And this is the module that takes the 400 volts from the tether, converts it into the 24 volts that the battery and the drone wants to see. Okay, and this flies in, this attaches on the back, and this gives you your power source. And then the second part, and this is also a very important part of every tether system, is the actual tether connection point itself. So this is the point on the Inspire 1 where the tether connects and where the force happens against the tether. So this can be pulled on and directly interacts with the center of gravity of the drone. And the electrical connection then hangs off. And we'll show you that as well on the M300. So this was the Inspire 1. We still support these systems. We still sell these. We do the battery modifications for you, so you ship us your batteries, and it's actually a great use for an old Inspire 1 where the batteries are getting hard to find, but the units themselves are actually completely functional and really quite nice, quite frankly. They make great units to fly off of a tether. Our next real iteration was into the M200 and M210. And this is our second generation M200 solution. And this solution takes advantage of these sleds that we have. And these sleds are units that take the battery and basically the battery slides into the sled unit. The sled unit itself slides in place of the battery. So you just slide it in where the battery would normally go. And then you can slide the battery into it, click it into place, and now there's two, one for each side. And this unit can actually fly right now as is. Doesn't need to be connected to a tether. The unit will automatically connect the battery to the drone in this configuration. If you then electrically connect again, the same XT90s, wrong side. You electrically connect them here with a T, and then you connect the BRM, the same BRM we had here, clips in here, and it's exactly the same configuration. So if we unconnect this, and I really don't like XT90 connectors, but they are. So this, again, same kind of setup here. You slide that in, you can make the connection to the tether right there, and then you connect your tether right here. So this, again, does the voltage conversion that feeds the two sleds that then feeds the tether power to the M200. Okay, so this was our previous high-end version, and we've taken many of the same ideas from that and applied it into our new M300 solution. So the M300 solution is essentially the same setup. You can see, again, we have two sleds, except for now, the high voltage tether wire is going directly into the sleds rather than through a BRM. So we've integrated the BRM functionality, the conversion from 400 volts to the 48 volts that this drone requires is now happening inside of each sled. So it's redundant, so you have two copies of each one. And again, same type of system, you can slide the batteries in and out as well. So we're gonna actually fly this thing first, and then afterwards, we're gonna show you the configuration changes and pull it out and show you how it's done. We'll take it down and some of that. So I'm gonna turn it over now to Todd Stave, who's our pilot in charge today. And I'll let Todd take you through flying on a tether.
Okay, great. Thank you, Rob. So here we are with the M300, and I have a nice little system here where I can sort of flip back and forth between the camera that is being focused on me and the drone and the actual drone camera itself. So I can share with you some of the things that I'm seeing on my screen to give you some sense of how the tether works. Let's go ahead and focus on the drone, and I'll go ahead and take off. Now, as it stands right now, while the tether is connected to the drone, it is powered off. So right now we're just flying on batteries, and we're going to just take off, and we're going to just stay there for a minute. Now I'm going to switch over to share my screen with you on the controller here. And what I want you to focus on a little bit is that the battery life, which is 95%, that's what we started with. In just a second, that flight counter is going to pop up, and it'll probably show something relatively normal, 35 minutes. There you go. Okay. So that's an important thing that we're going to sort of focus on a little bit for this demonstration. Rob, go ahead and turn the tether on now, if you would mind. Okay. So we got we just turned the tether on. I want you to keep an eye on that flight time counter. Notice how it is climbing, and it's going to climb very fast. It's going to probably get over 300. What that is that's a algorithm that DJI put on the system that basically calculates the depletion rate based on the amount of power you have. The system logically disconnects the batteries from the drone. So everything now that is powering the drone is from the tether system. Okay, so I'm going to switch back now to the camera so that you can see it climb out. As it stands now, we are hovering at about 5 feet above the ground. I'm going to go ahead and climb here. What you're focusing on now is that as it approaches the end of the slack at the end there, the cable pays out at a rate of about 3 feet per minute. I'm sorry, 3 feet per second, all right? And I'm going to stay here at about 42 feet-ish, all right? And I'm going to show you a little bit more on this drone here. So now let me switch back to the drone camera. Okay, so this is my telemetry. Okay, the flight time, as you see now, has climbed, up at the way above 200, and it's going to probably stay, above 300 by the time it's done counting. This drone is equipped with a Zinuse H220 camera, which is really cool. This is the regular wide-angle shot. If I want to see what they're having for lunch on the porch, I can zoom in here, which is really, really cool. This thing has got a 200x zoom on it. It's fantastic. This is the rest of the yard here. Let's see if I can put that. There you go. All right. So, and this is a IR view of what's going on here. We can tell if there's a fire in the barn or somebody in the truck or something that's kind of weird that's going on with that truck. We can zoom in to get an idea what the looks like, and we can probably even zoom in further if we wanted to get a picture of the license plate. Keeping an eye, of course, on that flight time. It has not changed. It's at 324 minutes. That's 9 hours, more than 9 hours. That's not anywhere close to reasonable for a drone like this. And a normal drone with these kind of batteries, as we saw when we took off, 35 minutes is a normal amount of flight time for a day like today. Okay. At this point, the show is kind of over. I mean, you could pretty much let this thing stay here all day long and not have to worry too much about what's going to happen. If you decide to let this, put the controller down and just let the drone fly by itself, the worst case scenario is, let's say something does happen to the tether. Let's say that there's a power failure. We're going to show you what that looks like in a minute. But what'll wind up happening is that it'll immediately switch over to battery power. And as the battery depletes, if you're still not paying attention, it's going to land. All right, I'm going to switch back to the outside camera here. There's Rob standing next to our box. And what he's demonstrating now is what happens if there's a strong wind. What happens if there's a big, honking wind? Well, we had this actually happen when we were demonstrating at the Aurora, Illinois Police Department for Darley a couple of years ago. Big wind, very gusty day. The drone was pretty much stayed in the air, but the cable would bow outward with a stiff wind. And as the wind dies down, the cable will straighten back up again. It's that easy. Okay, so now we're going to bring it back down. Rob is going to show you what happens in the event of a power failure. So we're descending smoothly.
Great. So as the drone comes down here, we're going to bring it down low so that you can see the effect next to the box. Okay. And so if you're flying off a generator, you run out of gas, somebody inadvertently pulls the plug out of the wall for whatever reason, or drives away with your vehicle that's powering it, whatever it is, you lose power to the ground unit. What will happen is that the unit will automatically switch back to the batteries. So I'm going to simulate that by just turning off the power switch. And if you watch the drone right now, you'll see that when it loses power, it will actually hop up a tiny bit in the air, about 6 inches, and then slowly settle back to where it's supposed to be. So 3, 2, 1. There you go. And now it's running on battery. And you can see we're all of 6 feet off of the ground. So, and absolutely no impact. Again, now we've gassed up. We can turn it back on again. So we turn the tether back on again, and it'll actually drop a tiny bit when it goes to the tether, and then climb back up. And there's that drop, and now it's going to slowly climb back up to where it's going to go. And we can do this all day long, turning power on and off. The electronics in there, it's all really very straightforward. It's a simple switch from battery to ground. And when I turn it off, what you'll see happen here again is I'll turn it off, and Todd can show you again that now when we go back to the control screen, you can immediately see that battery timer starts coming, and the flight time comes back down to what you would expect to be seeing in more of a battery-driven operation. And one of the questions we had earlier, have had in the past, is around what happens if the base unit loses power. Obviously, it's got no power. It can't warn you about anything. How do you know you have an issue? Well, number one, all of the normal flight controls in the drone are operational, so it will reach its auto land level eventually, and then will come down and land. Yeah. Yeah, exactly, and you'll see it on the controller. Oh, hey, perfect. So you'll see it come down and land, auto land. And one of the things about our solution on this unit, we're actually very happy with how this turned out. None of this interferes with any of the normal safety operational systems. So we have not turned off any of the side sensors, any of the downward-looking sensors. None of that has been turned off, and you can see even 6 feet off the ground, this drone is still absolutely rock steady in the air, even while it's hooked up and operating off of the tether. So you get that advantage. Okay.
Turn the power back on.
Yep. And I got to turn power back on again. One more time. And again, you'll see it drop a tiny bit as it switches over to tether. There's that tether switch over. And now it's sitting there running at tether. And again, we'll get to see the battery time immediately start climbing back up again in the process. Okay. Okay, good. Do you want to bring it down, Todd, and we can start taking, I don't know if there's any questions yet, and then we can also show you the components and how they go together and all the mount points.
Before we take it off tether, there was one quick question related to the tether, and that's whether we can control or adjust the level of tether tension.
Yeah, so on the RS1000, there is essentially no tension control. It's a fully automated system. It has about a pound of tension, which should be plenty to hold you in most winds and that sort of thing. That is something we're looking at, and we may do that type of control in a future system, but it's really related to supporting very different size and capability drones when you need that sort of capability, or you have a very unique need. We have some customers who fly them off of moving vehicles and things like that, and in those scenarios really need that type of capability a little bit more. One thing we're going to show you before we take it apart and show you the components, we may have seen something while we were flying, and so we want to come down, we want to get it off tether because we need to go fly over and take a closer look or whatever it is we need to do. And so in order to take it off tether, all we need to do is turn off the tether is a good start. We turn off the tether. We can even leave the drone powered up at this point. We need to disconnect the electrical connection. We need to unclip the mechanical connection. Okay, and now move the tether out of the way, and now we're ready to go. Okay, it's literally less than 30 seconds, and now you're back to flying your Ferrari. Well, maybe it's not quite a Ferrari, but it's a really nice SUV. And so you're back and all set. So it's very easy to connect and disconnect the tether. And again, the drone, even with everything else connected, is fully functional and completely can be flown completely autonomously. All right. Okay, Todd, if you want to bring it down. Great. And then we'll power it down here. And give DJI its moment to do its housekeeping. Okay, so now it's all off. And so now you can see that what we have here is we basically have these two connectors that hold the batteries in to each sled. With those open, so let's say we're flying loose, we need to come back, we need to go back to the scene. We can pull out the two batteries, pick up two new ones, slide them in, clip it in place, and off we go. Okay, so the sleds themselves in no way interfere with the normal operation of the drone, or we can unclip. This is the normal clip right here, obviously, that holds it. In this case, it holds our sleds in rather than holding in the batteries. And then we'll undo the electrical connection on this side, and then we can just, again, very similar to what you saw earlier on the M300. It's a sled, has the integrated electronics, so it has the heatsink now for the battery converter. Okay, and you're ready to go. All right, so you got that side. Obviously, you have the same issue on this side, same thing. So an M300 kit, the air module kit, is both of these connectors, the Y cable. And then the last part, and a very important part of the equation, is again the physical mount. And on the M300, that's this gray piece right here. It screws in on both sides where the leg screws are, two of the leg screws are, and then this is the physical mount. And again, now the tether is exerting force basically on almost dead center gravity of the drone. Which is always the best. And it's also back. It's away from any of the payloads you're flying on the front, and obviously it's away from any payloads on top in the flight. Okay. Okay. So that's the parts. Do we have any other questions, Carl?
We do. We have a couple questions here. First is, do you do any modifications or configuration changes that would have any impact on the DJI warranty?
No, there are no modifications to the batteries. There are no modifications to the drone, with the exception of removing, two of the screws on the leg on this side and screwing on the brace, which in no way is modifying the drone at all from a warranty perspective.
Okay, and the next question is, there's been some confusion and varying answers in regards to whether a Part 107 license is required when operating a drone on a tether. Do we have any, can we clarify that at all?
We can fly as long as we want to. In this scenario, I did not.
Okay. So what they were asking is that whether we need a Part 107 license to fly this drone, and the answer is that yeah, this is a drone like any other, and you do need a license, and you need to follow all the drone regulations. Now, with that said, there are some carve-outs for tethered flight, some that surround public safety, and it is also much easier to get a waiver for a variance on with a tether system because it's just inherently safer.
Yep. Yeah, I can't hear Carl's question.
Carl, what else? Anything?
That's all the questions right now.
Okay, great. This has been great, and I'll turn it back over to Carl to wrap up. Thank you all.
We've just got a couple other questions in, and any of the participants, if you have others, please keep those coming. So the next question is, are there any, what are the types of power sources that need to be used or can be used with the base unit to provide power?
So you can basically provide power to the base unit from a regular wall outlet. 110 volt, 15 amp regular wall outlet. You can provide power from a generator, typically a small 2200 watt, 2000 watt little Honda, the little quiet ones. They typically work pretty well. You need to make sure that the economy mode is off so that they spin up faster as it gets power draw as you start climbing. Lastly, obviously, you can run off of an inverter as well on a vehicle. Your lighter won't give enough power, but if you have a permanently installed inverter on a command vehicle or something of that nature, it can completely fly off of that. Depends on the size of the drone for the power you need. If you're flying a little Inspire 1, you can get away with you might get lucky, get away with about 1,000 watt inverter. If you're going to fly with an M300, with an H20T camera and 3 or 4 pounds of payload, then you're going to need, a 2,000, 1,500, 2,000 watt inverter. Depends again on the load and the power. Obviously, we also connect to other drones. Our BRMs are agnostic. They put out 6S, 12S, 4S. We can support all that. So there's a variety of US-made drones we support as well. And obviously, we haven't said this yet, but our unit is made in the USA, proudly made in Virginia, which is where Blue Vigil's headquartered as well.
And the next question is about operating in the rain. Is the unit waterproof, and can we operate in the rain?
So our M300, the air solutions for the M300, those are capable of operating to the same, essentially IP55 rating as the M300 drone itself. Although note that not all the cameras necessarily on the M300 can operate in those environments. So the air module is designed to match the capabilities of the M300. That is not true of our M200 and Inspire solutions. Those are not essentially rain capable at this point. Our ground unit today, it can deal with light mist and some light weather in that regard. But if there's going to be a heavy downpour or any serious rain, you need to protect the ground unit, which you can do by just covering it. And then if you need to fly, you can fly basically off angle and be a little bit away. And that operation can work quite well as well.
And any limitations or any payload types that we enable that aren't available today?
Well, so people use it for standard video surveillance, things of that nature. But we have other users who are using it and looking at using it for radio relays. If they want to put up a comms relay, if they're doing a larger area operation, if you're doing like a big forest fire or something, and you're trying to make sure you have radio capabilities out to dispersed field teams, you need line of sight. You can use the drone to carry a radio up into the sky and essentially create a radio relay. Things of that nature are obviously enabled. And then any operation where you need longer flight durations. We have people who are using it for very diverse uses, traffic studies, fish studies, flying off the back of a boat, looking at fish, all kinds of oil fields, all kinds of. Oh yeah. Oh yes, that's true. Todd just reminded me. We actually have a customer who's using it to create time-lapse photography of the cutting of mazes in cornfields, which is then used to show the folks who are coming to the mazes, so they can see basically the building of the maze. It's kind of a fun. It's kind of a fun customer to have, actually. A little bit unusual solution.
Next question is also related to payloads. Are there any limitations or any types of devices or cameras that you can't use when flying on a tether?
Generally, the answer to that is no. We have seen an unusual case related to a customer who wanted to fly a particular parachute system in conjunction with our tether system. And both the parachute system and our tether system used this sled design, and those two were incompatible. But that's a case where when those happen, then we've already working towards interacting with that parachute company to figure out how we resolve that issue, because there's no reason you shouldn't be able to use a parachute and the tether at the same time.
And you might have talked about this, but just to remind folks about warning sounds, lights, anything on the system.
Yeah, so that's a good point. So the RS-1000, it's not a complicated device to operate, but it does have a bunch of safety features in it. One of which is that as you get near the end of the tether, so if you have a 150-foot tether, as you get to around 140 feet, the box will both start to beep pretty loudly to alert you to that fact. And secondarily, the tether itself has a visual indicator. It has these red bars on it to warn you visually that you're at the end of the tether or near the end of the tether. And then when you reach the end of the tether, the box audio warning becomes more insistent. And then obviously also you'll quite frankly hear the tenor of the drone change in the sky because it's going to start pulling against something and the motors are going to start revving up, which will be an unusual sound at that point. And this actually comes into play if you're flying in strong winds. If you're flying in 20 or maybe gusting to 30-mile-per-hour winds, that wind can actually grab that tether pretty well. So that wind force against the tether can carry a fair amount of tether, and you might be carrying a bow that has an extra 20 or 30 feet of tether out to the side where the wind direction is going towards. And in that case, you need to make sure that the height you're flying at is low enough that that extra tether can be pulled in and out of the box in addition to your base flying height.
All right. Also related to payload and weight is, what does the tether add to the total weight of the system?
Yeah, so that depends a little bit, obviously, on from one system to the next. For the M300 system, it adds about 1.5 pounds of weight on the unit itself. plus you're carrying about 13 grams per meter of cable that you have out. So if you have roughly 100 meters of cable out, you're going to have a little bit of weight tacked on there. You got, so you might have 1.5 pounds or 2 pounds of cable on there. With that said, we have done flight testing with the M300 with all of the tether components on it, and carrying, I don't know, it's maybe 100 foot of cable, plus 4 pound, separate 4 pound payload, which is actually higher than the rated payload of the overall drone. Because one of the advantages, of course, of when you're flying from tether is that you don't have to worry about battery power. So the M300 is actually a very powerful unit and can theoretically carry a good chunk more weight than it's rated for, but the battery life collapses very quickly in that scenario. And when you're flying off tether, you don't really have that issue.
And can you cover once again the aircraft other than DJI that we're compatible with?
Well, we've flown with a bunch of different aircraft, everything from unique H520s in the past, Lockheed drones, Ascent Aero Systems. We've worked with Planck has units, several other folks. We're essentially agnostic to the drone. And we can, if somebody has a unique drone or has a specific drone they have a question about or how to integrate to it, they should please get in contact, and we can walk through what it would take to support that. You don't need a ton on the drone. You need to have a way to get into the power path for the batteries, and then you need a mount point. You need to find the appropriate mount point, build some mechanism to mount to carry the tether force.
Any drone that is powered with a generic LiPo battery, you can plug directly from our XT90 connector that you saw earlier directly into the drone itself with zero modification. We initially called that device, or we still do really, the BRM, or the battery replacement module, for that reason. You could take the battery out completely if you wanted to and plug that one in.
Yep. It's also why it has an XT90 connector on it.
All right, looks like we have just one final question here. This individual would like to know where are the Blue Vigil units manufactured?
They're manufactured in Virginia, in the United States, in the great state of Virginia.
All right, well, unless there are any last minute questions that didn't get answered, we're going to go ahead and wrap this up. So I'm going to turn it over to Bruce at this point.
All right. Again, thank you very much for everybody for attending today. Again, I apologize for my video as I am on scene doing some training today. But again, thank you all for taking the time to watch and listen. I believe I posted my email address on the chat site, which is Bruce Ireland, IRELAND, at Darley.com. Please feel free to reach out to me with any questions. For those of you that attended today, we will offer you a $500 discount off MSRP. So if you would like a quote, feel free to reach out to me. We'll get that taken care of you. If it's something that you need a demo, let me know, and we'll see about making some arrangements for that as well. But again, thank you all, and let me know how we can be supporting you and your agency.
Great. Thank you, Bruce. We really appreciate the partnership with Darley. They're one of our authorized dealers. We've been working with them for a long time. So thank you, everybody, for attending. We're excited about the M300. I think that this is going to become probably the next kind of workhorse enterprise drone in the public safety space. We're happy that we're integrated with it now. In terms of availability, just so you're aware, we are about to launch kind of a final short beta test with just a handful of agencies. If you have any interest in becoming a beta partner, if you've already got your M300 and you really want to get on a tether, contact Bruce. We can figure out how to make that happen. And we've got another $500 on top of what he mentioned for beta participants. And in terms of general availability, we're looking at the end of May to have units available. We're taking orders now, and we'll be shipping by the end of next month. So again, thank you very much for your time this afternoon. I hope it was informative. I hope you learned a lot. But again, if you have any questions, Bruce and the team there at Darley can help you with all your other questions. Thank you again. Have a great day.
Thank you all. Thank you, Carl.